So we're going to continue with polygons. Today, in particular, we're going to talk about parallelograms. All a parallelogram is, it's a quadrilateral, which means it has four sides, with two pairs of parallel sides. So if I mark up this picture over here, so this double set of arrows and that double set of arrows means that BC is parallel to AD, and single arrow means AB parallel to DC. So again, all a parallelogram is, it's a quadrilateral with two pairs of parallel sides. Alright, this extremely important what's going on inside this little diagram. So we start with the middle. Again, I just defined parallelogram again. So parallelogram definition is just a quadrilateral with two pairs of parallel sides. So again, I just wrote down the definition again. So now there's all these little bubbles. First property, the first thing that we need to know about parallelograms is that the diagonals bisect each other. That's very important. We need to memorize that. Just remember that. If I have a parallelogram, the diagonals bisect each other. If we forgot what bisect means, bisect just means to split into two equal parts. So the diagonals split each other into two equal parts. That's the first thing we need to remember about parallelograms. Second thing, consecutive angles. Consecutive means next to each other, like they're in a row. Consecutive angles are supplementary. Gotta have to remember that. Opposite sides are congruent. You gotta remember that about a parallelogram. The opposite sides, the sides that are opposite one another, are congruent to each other. And the last thing we're gonna have to remember is that opposite angles are congruent to each other. So going back to this picture up here, angle A and angle C are going to be equal to each other, and angle B and angle D are going to be equal to each other. Consecutive angles, it means the angles next to each other are supplementary. So angle A plus angle B must be 180 degrees. Angle A plus angle D must be 180 degrees. And so on. Okay. At the bottom, it just wants you to draw some pictures. It's kind of hard to read, kind of blurry, so I wrote in what maybe you might not be able to read. It says, draw a picture of a parallelogram showing the opposite sides are parallel. So I just basically drew the same picture that's up above. I drew a parallelogram. Two arrows means those sides are parallel. Arrow means those sides are parallel. Now it wants me to draw a parallelogram with opposite sides being congruent to each other. So what would that kind of picture look like, and how would I mark it up on my paper? See if you can do it on your own. How would I draw a picture of a parallelogram indicating that the opposite sides are congruent to each other? We're going to use the tick marks. So two ticks there and two ticks there means these two sides are congruent. One tick means these sides are congruent. Opposite sides are congruent to each other. Okay, and this one says opposite angles are congruent to each other. So again, how would I mark up my picture showing that the opposite angles are congruent to each other? I could just do something like this. Same parallelogram, two arcs, so these two angles are congruent. One arc, these two angles are congruent. Okay? Consecutive angles are supplementary. So what would that look like? That the consecutive angles are supplementary. What would that picture look like? It would look something like this. Same parallelogram. So if I call this angle X and this angle X, then this angle must be 180 minus X, and this angle must be 180 minus X. If the diagonals bisect each other, what does that picture look like? It looks something like this. So two ticks, so those are equal to each other. One tick, those are equal. So yeah, this might not look like a lot of notes, but this is extremely important. This little picture. We need to have all this stuff down. It would be better if you knew all this stuff by the time you came to class, so we could just start working problems. That's the whole point of having the flipboard. Again, not to be experts, but to have an idea of how this stuff works. Okay, so now let's put this stuff to use. See if I can get some of it to show. Right. Alright. It tells me I have a parallelogram, JKLM. It tells me LM is 86 millimeters. So I marked it there. There's 86 millimeters from M to L. LK is 100. And the measure of JML is 42 degrees. It just wants us to find the rest. Again, try as much as you can on your own. Pause the video, see if you can do it using what we have on the previous page. Okay, if you can't, hopefully you're back now and you've got most of them answered. We're just going to go one by one. Well, JM has to be 100. Remember, opposite sides are congruent to each other. So this is 100, then JM M must be 100. KJM, KJM. So they're talking about angle J. They want to know the measure of this angle. Well, if M is 42, these are consecutive, so they must be supplementary. Just do 180 minus 42. KJM must be 138. Okay, KJ. KJ is 86. Why is it 86? Because it's opposite from ML, and we already know that ML is 86. It told us up here. And LKJ, angle K. Angle K is opposite from angle M. They must be congruent, so angle K must be 42 degrees. And angle L and angle M are consecutive angles. They must be supplementary. If that's 42, this must be 180 minus 42, or 138 degrees. Okay, I do understand that my examples that I do on this are a lot easier than the problems we do in class. I get that. This is just to give you an idea, and then we do try to get to the harder stuff in class. Okay, so now I've got another parallelogram, so if I can get it to show up. There it is. It says I've got parallelogram ABCD. So I go back to the other page, and what do I remember? I remember that the diagonals bisect each other. It means they cut each other into two equal pieces. So when I go back to this picture, I should see, or it should be sounding maybe alarms in your head. Oh, I've got the diagonals. The rule is, if it's a parallelogram, the diagonals bisect each other. It means they cut each other into equal pieces, which means BE must be equal to ED, and AE must be equal to EC. That's what the diagonals do. They cut each other into equal pieces. So then I can go down here. Well, then y plus 10 must be equal to 6y, because AE must be equal to EC because they're bisected. Do a little bit of algebra, and I get that y is equal to 2. So once I get the y is equal to 2, it wants to know what AE is. Well, AE is just y plus 10, but I know from down here that y is 2. So 2 plus 10 gives me 12. Okay, look at the other diagonal. Well, BE must be congruent to ED. So I should be able to set 4x minus 6 equal to 3x. So 4x minus 6 equals to 3x. Add 6 to both sides. Actually subtract 3x from both sides, then move the 6, and you get x is equal to 6. So BE is equal to 4x minus 6, but we just figured out that x is 6. So 4 times 6 is 24, minus 6 is 18. Once we've got these, again, we can figure out what the rest of these are. All right, one more example. Again, it tells me I have a parallelogram. So again, I should know that my consecutive angles are supplementary. I should be able to add these two up, and it must be equal to 180 degrees. So that's what I did. I did 4x plus 7x plus 15 equals 180 degrees. 4x plus 7x is 11x. Subtract 15 from both sides, and I get x equals to 15. And then once I get the x, I can just plug it back into here. So then x must be 60, and w is equal to 120. Okay, so this is what we need to come to class with an idea of how this stuff works. We'll spend the whole class reviewing, doing some more of the polygon stuff we did yesterday with interior and exterior angles, and then we'll hit a bunch of these.